When you think of infrastructure in the United States, the first things that probably come to mind are the iconic orange-red cables of the Golden Gate Bridge or the endless stream of cars on the interstate highways. These are, without a doubt, symbols of American pride. After all, the Golden Gate Bridge was completed in 1937, and the Hoover Dam stunned the world way back in the 1930s. But today, let's shift our focus halfway across the globe, to China. There, a groundbreaking infrastructure revolution is unfolding, one that is redefining the scale, the speed, and the technological limits of what we once called engineering marvels. This is the story of China's infrastructure, a story of breathtaking ambition and record-breaking projects, of a nation reshaping its landscape at lightning speed and rewriting the global playbook for what infrastructure can achieve. Can you believe this? While America is still stuck in endless debates, just to renovate a single bridge, China has already built the tallest bridge on Earth, suspended between cliffs as high as a 200-story skyscraper. While American high-speed rail proposals are still stuck in Congress, China's bullet trains are racing at 421 kilometers per hour across a staggering 40,000 kilometers of high-speed rail, more than the rest of the entire world combined. This isn't a sci-fi movie. This is real. This is China, redefining what's possible in engineering, one mega project at a time. To be honest, when it comes to infrastructure, the gap between China and the US might be far bigger than you think. Take high-speed rail, for example. America's first high-speed rail project, the California High-Speed Rail, was approved back in 2008. And the result? 16 years later, it's still not finished. The original budget of $33 billion has ballooned to over $128 billion.
So we're here to talk about the California High-Speed Rail Project. So when originally conceived, the voters of California voted in Proposition 1A that they would have a high-speed rail from LA to San Francisco. It was going to be done by 2020, and it was going to cost $33 billion. And people were excited, they were thrilled, take people off the road, out of the air, put them on rail, move them quickly. It was an exciting time, exciting promises for an exciting project. Where are we today? Well, today, we are severely, no pun intended, off track. And that project, thus far, is going to cost the California taxpayer and the federal taxpayer, at best estimates, $33 to $35 billion. At best, that portion of the project is not going to be completed until 2033, 2035, way after this whole project was to be completed. And with the $15.7 billion already invested in a project that has given you bridges here to my left and to my right, bridges to nowhere, right? But this project, if completed, 400 miles from LA to San Francisco, at best, it'll cost $106 billion. Now, most people will say that is a rosy estimate. There's no way it's going to be completed for $106 billion, which, just to do some simple math, that's 3 times.
Meanwhile, in China, since the Beijing-Tianjin line opened in 2008, China has built over 40,000 kilometers of high-speed rail, enough to circle the Earth at the equator, and then some. And the kicker? China's average construction cost is only 1/5 of California's high-speed rail project. It's like China is riding a rocket while the US is still on a bicycle. From the frozen highlands of the north to sun-drenched tropical shores, China's vast high-speed rail network keeps racing forward day in and day out. Now let's talk bridges. Sure, the Golden Gate Bridge is iconic, but today, 42% of US bridges are past their intended service life, causing an estimated $110 billion in economic losses every year due to aging and deterioration. In contrast, China is home to 8 of the 10 longest sea-crossing bridges in the world. And the construction efficiency? Absolutely staggering. In the US, building a standard bridge can take 7 to 10 years. But in China, advanced pivot technology has made it possible for a 16,300-ton bridge to rotate 180 degrees and connect in just 90 minutes. In 2019, the Pingshan Bridge in Hebei completed its pivot in only 85 minutes, a new world record. One American viewer even joked, "Do people in China have more hours in a day than we do?" So where does this massive gap come from? It boils down to fundamentally different approaches to infrastructure. In the US, projects often get stuck in endless rounds of approvals, local opposition, and political tug-of-war over funding. But in China, centralized planning and powerful execution enable the country to rally national resources for major challenges. Just look at the Hong Kong-Zhuhai-Macau Bridge. More than 1,400 companies and tens of thousands of engineers work together on a single goal. That kind of nationwide coordination is nearly impossible to replicate in the US. And yet, in the face of what many consider a modern engineering miracle, some voices online from the US have raised doubts. With China's current level of industrial development, can this bridge really hold up? I bet it'll need a full overhaul in just a few years. It can't compare to Brooklyn Bridge, USA. This is just a showpiece, no real use. Just trying to flex on the world stage. A waste of money, purely symbolic, with no real benefit to the region. But these dismissive comments reveal less about the bridge and far more about their own comprehension limits. They conveniently ignore the 1,000-plus patented technologies developed during the construction. They overlook the 6.7-kilometer undersea immersed tunnel, built with a precision tolerance of less than 5 millimeters. And they're unaware of the bridge's advanced design, with multi-layered anti-corrosion systems, seismic resilience, and the ability to withstand Category 16 typhoons, magnitude 8 earthquakes, and even a 300,000-ton ship collision. When Chinese engineers declared a 120-year design lifespan, it wasn't a marketing slogan. It was backed by hard data, rigorous testing, and world-class engineering. These unfounded criticisms aren't just about the bridge. They're about the growing unease of watching China's engineering capabilities rise, with a speed and confidence the world didn't expect.
Oh God, please, no! No!
Imagine this. Beneath the roaring waves of the Lingdingyang Strait, 33 massive immersed tunnel segments, each as tall as an 8-story building and weighing 80,000 tons, had to be aligned and joined together with Lego-like precision. The margin of error? No more than 5 centimeters. The difficulty? Comparable to threading a needle through a moving aircraft carrier during a hurricane. This was the hell-level challenge Chinese engineers faced while building the Hong Kong-Zhuhai-Macau Bridge. John Smith, a member of the American Society of Civil Engineers, once said, "Achieving millimeter-level precision in deep-sea immersed tube joints, we used to think that was impossible in the real world." Faced with such skepticism, even ridicule from overseas experts, Chinese engineers responded with quiet determination. Yes, the difficulty is unprecedented. Millimeter-level tolerance in these conditions is an enormous challenge, but that's exactly why we must do it. This is our responsibility as Chinese engineers. We will not be intimidated by mockery or doubt, and no technological blockade can stop our progress. We will stay on site, research day and night, and even if we fail thousands of times, we will never give up. And they didn't. Through relentless effort, they invented a technique called composite foundation treatment, injecting special materials into the seabed to turn soft silt into rock-solid support, capable of holding tens of thousands of tons. During testing, engineers worked 72 hours non-stop, failed 137 times, until they finally achieved a 300% increase in load-bearing capacity. On May 2, 2017, during the connection of tunnel segments E29 and E30, a sudden tidal surge knocked them 3 centimeters off alignment. In that critical moment, China's self-developed dynamic hydraulic adjustment system kicked in, and within just 15 minutes performed a millimeter-level correction. This move didn't just save the project, it rewrote the rules of sea-crossing tunnel construction worldwide. Today, the 55-kilometer-long Hong Kong-Zhuhai-Macau Bridge is not only the longest sea-crossing bridge in the world, it's a bold symbol of China's engineering prowess. Next, let's talk about water engineering. The Hoover Dam was once a global icon of industrial might, its power output unmatched for decades. But today, China's Baihatan hydropower station has taken center stage. Its network of underground chambers stretches over 217 kilometers. That's the length of 300 Empire State Buildings stacked end to end. The largest cavern is 438 meter long, 34 meter wide, and 88.7 meter tall. Hence can easily accommodate 13 Boeing 737 aircrafts. And in terms of output, it generates 3 times the electricity of Hoover Dam. Even more astonishing, while America's Big Dig in Boston went 220% over budget and suffered decades of delays, China built Beijing Daxing International Airport, a massive starfish-shaped megastructure, in just 4 years. It handles 200,000 passengers a day, and secured 60 international patents in the process. While some countries spend a decade debating a single bridge or railway, arguing over budgets that keep doubling, China has already been building world-shaking mega-projects between sheer cliffs, beneath the deep sea, and across frozen permafrost. This isn't science fiction. It's not a vision of the future. It's happening right now. Bridges soar across canyons as tall as 200-story buildings. High-speed trains race through snow-covered plateaus once considered uninhabitable, and metro systems spread through cities like arteries, connecting an entire nation at astonishing speed. That's why China has earned a global nickname, the infrastructure powerhouse. Not as sarcasm, but as a reflection of the world's genuine shock at China's engineering capabilities. As one of the world's largest developing countries, China chose a very different path to growth. Connect first, then develop. Build infrastructure first, then unlock economic takeoff. To Chinese engineers, mountains are not obstacles, oceans are not boundaries, and extreme environments are simply the next challenge to overcome. In this video, we'll take you behind the scenes of China's massive engineering projects. Projects that leave global engineers speechless and foreign audiences in awe, to see how they were built and how they're reshaping a nation's destiny step by step. As an old Chinese saying goes, if you want prosperity, build roads first, because only when people and goods can truly move can a nation's growth truly begin. And with a population exceeding 1.4 billion, China has no choice but to manage its resources, transportation, and energy systems in the most efficient and sustainable way possible. The infrastructure being built today is not just about expanding usable space. It is about laying the groundwork to become a global leader in technology, engineering, and energy. That includes towering bridges engineered to withstand typhoon-force winds, ultra-long tunnels driven through frozen mountain ranges, and direct sea crossings that turn vast bays into journeys of just minutes. It also includes the world's largest radio telescope, built to detect signals from deep space, and drilling projects that plunge tens of thousands of meters underground to uncover the secrets of the Earth itself. China is even transforming deserts into hubs of clean energy and new farmland, achievements once thought impossible, now becoming reality. Together, these projects show that China is not building simply to compete with other nations, but to demonstrate on its own terms a determined and unmistakable path toward the future. So what does that future actually look like? It looks like tunnels drilled beneath oceans, bridges hanging higher than clouds, railways carved through frozen mountains. Let's take you inside the mega projects making it real. As an old Chinese saying goes, to get rich, build roads first. Indeed, transportation is the cornerstone of economic development and a crucial guarantee. Prosperity can only come when people and goods can move smoothly. Engineering and technology are forces that reshape the world, accelerating the wheels of history and fueling the progress of human civilization. Today, as China rises to become the world's second-largest economy and the leading manufacturing powerhouse, it is also proving its extraordinary engineering capability, gaining global recognition as an infrastructure giant. A series of breathtaking mega projects has showcased China's national strength and vitality to the world. Amid global economic shifts and China's new stage of development, these projects, defined by their massive scale, technical complexity, enormous investment, and long-term impact, span transportation, construction, water management, energy, and even defense. In just a decade, China has built and put into operation 45,000 kilometers of high-speed rail lines. By comparison, Japan and Europe took nearly 3 times as long to develop their own high-speed networks, and their scale is only a fraction of China's. Today, China's high-speed rail network alone exceeds the total of all other countries combined. Technologically, it has moved from importing to leading, pioneering the high-speed rail 4.0 era. The Three Gorges Dam is the largest and most complex hydropower project on Earth. The south-to-north water diversion project is the most ambitious interbasin water transfer in human history, and the land reclamation in the Nansha Islands has been hailed as a miracle of nature's craftsmanship. And among these mega projects, one is pushing the very limits of human engineering, the world's largest island-to-land connection project. From the sky, you're about to witness one of the boldest engineering feats on Earth, the Hoover Bridge, the world's largest island-to-mainland connection. Its 1,650-meter main span leaps across the sea in a single breath, holding the crown as China's longest-span bridge for 10 years straight. But this is just the beginning. Together with the Jintang, Taoyaomen, Shangjiaomen, and Shengang bridges, a chain of mega bridges stretches nearly 50 kilometers, binding once isolated islands into one seamless whole. 9 years later, the 8-kilometer Yushan Bridge rose to link Yushan Island with Daishan Island. 12 years after that, the 25-kilometer Zhoushan-Daishan Bridge connected Daishan Island to Zhoushan's main island. Together with the 32.5-kilometer Donghai Bridge, which links Shanghai to Shaoyangshan Island, and the Liuheng Highway Bridge now under construction, a series of expressways have stretched across the sea, building new land right above the waves. The result? China gained the world's busiest cargo port, the second-largest offshore green petrochemical base, and its very first major fishing ground. This is not just a bridge. It's a super connection that reshaped China's coastline and redefined what's possible in modern engineering. After conquering cross-sea bridges, China has set its sights on an even greater challenge: undersea tunnels. Here, you are about to see the world's longest undersea high-speed rail tunnel, the Jintang Undersea Tunnel. Stretching 16.18 kilometers in total, with 11.21 kilometers of shield-driven section beneath the seabed, this tunnel is nothing short of a super engineering feat. Its cross-section measures a massive 14.5 meters in diameter, as tall as a 5-story building, large enough to accommodate dual high-speed rail tracks. The construction relies on the colossal shield machine, Ding'ai, with a cutter head nearly 15 meters across. Its steel blades work like the fangs of a giant beast, slicing through layers of rock and soil. Guided with pinpoint accuracy by China's Beidou satellite navigation system, it advances toward another shield machine, Yongzhou, coming from the opposite direction. Deep under the seabed, the two machines will finally meet with millimeter-level precision. So why is the Jintang Undersea Tunnel hailed as the world's #1? The key lies in one word: high speed. Its design speed reaches 250 kilometers per hour, far exceeding the Channel Tunnel between Britain and France and Japan's Seikan Tunnel. By high-speed rail standards, Jintang's length and scale are unmatched anywhere on Earth. But the greatest challenges are not just about being long. The tunnel runs 78 meters below sea level, where shield machines must withstand enormous water pressure. Along the route, they face 28 geological transitions, alternating between solid rock and soft soil. To overcome this, engineers made special modifications, adding water injection pipes on the cutter head to handle sticky clay, reinforcing the sealing systems to resist extreme pressure, and upgrading the drive system for long-distance stability. Construction follows a dual shield approach. Yongzhou advanced 4,940 meters from the Ningbo side. Ding'ai dug 6,270 meters from the Zhoushan side. Why the difference? Because the geology is uneven. Rock on one side, softer soil on the other, making symmetrical digging impossible. The final meeting point was deliberately chosen within a stable rock formation, the only way to guarantee a safe and accurate junction. And accuracy is everything. In an undersea tunnel, even the tiniest error in manual surveying multiplies over distance. One wrong calculation, and you could end up with 2 separate tunnels instead of 1. To prevent disaster, engineers deployed 6 Beidou satellites linked to the shield machine's auto-navigation systems, correcting deviations in real time. In the end, the alignment error was kept within just 2 centimeters. Then came the final challenge: how to remove the machines. When the two titans meet underground, there is no exit ahead and no way back. The solution? A technique called shedding the shell. The shield machines are dismantled piece by piece and hauled out, while their massive steel casings remain in the tunnel, permanently reinforcing its structure. According to plan, the Jintang Undersea Tunnel will be fully bored through by the end of 2026 and open to traffic with the Yongzhou Railway in 2028. Once complete, passengers will be able to travel from Ningbo to Zhoushan in just 30 minutes by high-speed train, ending the island's long history of having no rail connection. And while officials may not say it openly, many already see the bigger picture. This tunnel is not just a passage to Zhoushan, it may well be the testbed for the Taiwan Strait Tunnel. If China ever attempts to build across the strait, this will have been the most critical rehearsal. So, just how advanced is China's technology for building underwater tunnels? To answer that, let's take the Hong Kong-Zhuhai-Macau Bridge Tunnel as an example. Here's the big question. The ocean is full of water. So how do you build a tunnel beneath the seabed? And how did Chinese engineers manage to construct a 6.7-kilometer underwater tunnel 40 meters below sea level? At first, engineers considered using tunnel boring machines, But since TBMS require extremely high stability, the tunnels they dug went much deeper than the design required. That meant they needed another solution. Their goal was to build a massive sea-crossing bridge that could connect Hong Kong, Zhuhai, and Macau, a project now hailed as one of the 7 wonders of the modern world. The final solution was immersed tube tunnel technology. In this method, trenches are dredged on the seabed. Prefabricated concrete tunnel sections, called immersion tubes, are then lowered into these trenches, aligned underwater, joined together, and finally backfilled with sand and gravel. Each tunnel section is 180 meters long, weighing 76,000 tons, about the same as an aircraft carrier. Each one contains 2 3-lane carriageways and 2 service tunnels. Chinese engineers had to lower and align these massive tubes one by one, but manufacturing a single 180-meter, 76,000-ton reinforced concrete unit in one piece was practically impossible. The solution? Engineers divided each tunnel section into 8 smaller parts, prefabricated them in a factory, and then joined them into a single 180-meter unit. In total, the project consumed 330,000 tons of steel and 2 million tons of concrete, enough to build 8 Burj Khalifa towers. On the uninhabited Niutu Island, over 3,000 workers built a massive factory in just 100 days. Its only task to produce the 33 immersion tubes required at a rate of 2 per month, each weighing 76,000 tons. After more than 1,400 days of construction, nearly all tunnel sections were in place. The final piece, E30, was carefully lowered into position. Slowly, steel cables lowered the giant section to the seabed, while engineers above monitored every detail in real time. After 26 hours of precise adjustment, E30 was finally seated in place. Divers then entered the seabed, carrying out millimeter-level measurements to ensure the alignment was perfect. Once confirmed, the last segment was sealed, and the world-shocking Hong Kong-Zhuhai-Macau Bridge Underwater Tunnel was complete. This is not just about a tunnel. It's about speed, precision, and national ambition. A netizen compared China's rise to human learning. You get smarter from both success and failure. China is like a sponge, absorbing and improving technology. Many of these mega projects are not done for show, but to make things better. As one user put it bluntly, the US spends over $1.5 trillion on defense instead of modern infrastructure. Imagine what both countries could achieve if they worked together on infrastructure. One foreign commenter said, "These mega projects showcase China's engineering prowess and ambition, reshaping the country's landscape and connecting its vast population." But these projects come at a hefty price, often hidden from public view. The construction of these mega projects often involves massive land acquisition, deforestation, and the displacement of local communities. The environmental impact of these projects is significant, contributing to air and water pollution, habitat destruction, and climate change. Recent examples include the Three Gorges Dam, which displaced millions and altered the natural flow of the Yangtze River, and the Belt and Road Initiative, which has raised concerns about environmental sustainability in participating countries. While these projects promise economic growth, they often come at the expense of social equity and human rights. The construction of these projects has led to forced evictions, the suppression of dissent, and the exploitation of laborers. The lack of transparency and accountability surrounding these projects raises concerns about their social and ethical implications. As one of the world's largest developing nations, China has used infrastructure as a powerful engine for economic growth. And at the heart of it all are Chinese engineers, modern-day heroes who are quietly reshaping the world. From undersea tunnels to the tallest bridges on Earth, from expressways carved through deserts to ultra-long-distance power transmission grids, each project is a testament to what human engineering can achieve when ambition meets precision. These projects are not just massive in scale. They showcase China's world-leading capabilities in structural design, smart construction, and sustainable technology. Now let's explore these jaw-dropping mega projects and see how China is redefining what's possible in the world of infrastructure. So why has China earned the nickname Infrastructure Maniac from the West? It's simple. When the funding is in place, Chinese construction teams can deliver incredible speed without compromising on quality. In contrast, many foreign teams look helpless when compared to China's pace. Take New Zealand, for example. They've been trying to build a mere 300-meter subway tunnel beneath a city center, and after 4 years, it's still unfinished. Now imagine if this project were handed to a Chinese construction team. Not only would 300 meters be done in no time, even 3,000 meters could be completed within 2 years. In Africa, the Chinese-built Mombasa-Nairobi Railway revolutionized transportation in Kenya, connecting cities that had never been linked by rail before. The deep friendship between China and Kenya continues to flourish to this very day. Thanks in part to the Mombasa-Nairobi railway, communication between the two nations has gotten even closer.
Yeah, with the Chinese experience, they've built the Tibetan railway, they've built long railway lines, passing through the parks. And when they build this, they take into consideration the needs for preserving the environment. Yeah, that experience is important in the African context.
Meaning of the bridge basically is linking this group of people to the other group of people. So as you understand this group of people, the Chinese, and I understand my countrymen, then I connect in terms of language, in terms of way of thinking.
Why is China so eager to spend massive amounts of money on helping Africa with infrastructure development? Some find it puzzling, even questioning whether deeper motives lie beneath China's grand efforts.
Been very concerned lately about China. They're in Africa. They're lending money to countries to build ports and different infrastructure.
To build what?
Port,
And what's wrong with that?
And, well, because...
Countries that need ports, get ports.
But they're making people dependent on... I mean, I know, it's the same thing that we've done, which is
No, it's not.
horrible around the world.
They are far more humanistic than the United States ever was.
Really? Okay.
Absolutely.
Great.
Let me give you an example. Of course, they are peddling for influence.
Yeah.
Yeah. But they are non-interventionist. Absolutely non-interventionist in a way that Europeans, the West, has never managed to fathom. The Chinese never asked Apple to go to Shenzhen and produce all the iPhones. It was Steve Jobs that decided that. Yeah? Mm-hmm. It was not China that went to Washington, D.C. and demanded that they buy a third of your national debt. If they hadn't bought it, you would be in serious trouble. When it comes to the influence of China outside its borders, it's quite remarkable that they don't seem to have any military ambitions. Instead of going into Africa with troops, colonially, destroying the country, killing people like the West has done for the last 100 years, what they did was they went to Addis Ababa and they said to the government, we can see you have problems with your infrastructure. We would like to build some new airports.
In the Middle East, China's work on the Khalifa port in the UAE and metro systems in Saudi Arabia redefined construction expectations with record speed and unmatched precision. In Southeast Asia, the Jakarta-Bandung high-speed railway stunned the world. Designed, built, and now operated with Chinese expertise, it marks a major milestone in global high-speed rail development. This project stands as a flagship of China's Belt and Road Initiative, backed heavily by Chinese state-owned giants. It is operated through a powerful joint venture between Indonesian state-owned enterprises and leading Chinese railway companies. Initially projected to cost under $5 billion USD and opened by 2019, the plan was soon derailed. Construction hurdles and the shock of the COVID-19 pandemic sent costs soaring past $7 billion. Now, the Indonesian government is pushing forward, aiming to extend the 142-kilometer rail line even further. A train running on the Jakarta-Bandung high-speed railway has reached a speed of 350 kilometers per hour for the very first time during a test run. This milestone marks a major achievement. The railway has officially met its design speed standard and successfully completed the interim goals of dynamic testing, which began on May 22nd. Over the past month, the inspection train gradually accelerated, moving from 180 kilometers per hour to 350 kilometers per hour. Now all functionality, performance, and barrier system indicators of the HSR have met the required design standards, paving the way for future trial operations and the official launch of service. In upcoming tests, the train is expected to reach speeds of up to 603 kilometers per hour. This high-speed line, a landmark project under China's Belt and Road Initiative, connects Indonesia's capital city, Jakarta, to another major city, Bandung. Once fully operational, the railway will slash travel time between Jakarta and Bandung from over 3 hours to just around 40 minutes. This is far more than a railway. It's the embodiment of speed, the hallmark of innovation, and a testament to engineering brilliance. Moreover, it marks a crucial milestone in China's infrastructure going global. So if we want to judge the true level of Chinese infrastructure, We should look at the project still running strong, still serving millions, rather than magnify the outliers. Why are foreign teams so slow? One major reason is the 6-hour workday culture. Workers clock out on time, no overtime, no exceptions. Half the time is spent chatting, the other half actually working, leaving perhaps 3 hours of true productivity per day. And then there's the pampering. Too sunny? No work. Raining? No work either. Harsh weather? Take the day off. With that kind of mindset, how can projects possibly move forward? In contrast, Chinese construction crews are famously efficient. In China, if a skyscraper takes more than 2 years to complete, it's considered delayed. Now let's take a look at what was once the world's highest bridge, the Beipanjiang Bridge. 883-foot main towers, equivalent to stacking 2.5 Statue of Liberty monuments vertically inside the canyon. 22,000 tons of steel deck, capable of bearing 3 tons per square meter, and designed to withstand a once-in-a-century blizzard. 250 miles of steel cables, if combined into a single cable, their strength would be sufficient to lift 3 Nimitz-class aircraft carriers. U.S. civil engineering experts candidly admitted, if this bridge were built in the United States, it would take at least 12 years. China completed it in just 5. They even installed AI-based monitoring systems on both sides of the canyon to adjust cable tension in real time. As you drive across this bridge, the experience feels almost unreal. Nearly 2,000 feet below, a vast canyon opens beneath the roadway, with the Beipan River surging violently at the bottom. The view is both breathtaking and unsettling. From the edge of the deck, the steep walls of the Beipanjiang Gorge drop away abruptly, and every glance downward is enough to take your breath away. Despite its enormous construction costs, the bridge shattered multiple world records through its sheer height and engineering innovation, further cementing China's position as the country with the greatest number of ultra-high bridges on Earth. But this raises an important question. Why are so many of China's bridges built so extraordinarily high? To answer that, let's step inside the remarkable story behind the construction of this bridge. The Beipanjiang Bridge is located in Guizhou Province, southwestern China. It soars above the Beipan River, with its deck standing 854 feet above the water, a height comparable to a 200-story skyscraper. The structure is a 4-lane cable-stayed bridge, positioned along the border between Guizhou and Yunnan provinces, a region notorious for its rugged terrain and extreme transportation challenges. Spanning 4,399 feet across the canyon, the bridge provides a safe yet awe-inspiring route through a landscape that was once extremely difficult to traverse. That convenience, however, came at a steep price. The total project cost reached approximately $147 million. Completed in 2016, the bridge became the highest bridge in the world at the time, officially entering the Guinness World Records in 2018 due to the height of its deck above the valley floor. It's important to clarify that the title of highest bridge does not mean tallest bridge structure. France's Millau Viaduct, which cost around $424 million, is renowned for its towering pylons, yet its deck height above the ground is far lower than that of the Beipanjiang Bridge. The Millau Viaduct reaches a structural height of 336.4 meters, while the tallest tower of the Beipanjiang Bridge stands at 269 meters, ranking 10th globally in tower height. What the Beipanjiang Bridge truly set a record for is deck height above ground. So if anyone ever asks how much you know about bridges, here's a useful piece of trivia. Tall bridges and high bridges are not the same thing. Beyond its height, the bridge also features the second longest steel cable-stayed span in the world. But how did this structure manage to break so many records and become a global symbol of modern engineering? Construction of the Beipanjiang Bridge took 3 years, finishing in 2016. But planning and design began much earlier, in 2011. The project initially received about $1.37 million in scientific research funding from the Chinese government. Additional matching funds of roughly $937,000 were later added, bringing the total research investment to $2.3 million. Designed entirely by Chinese engineers, the bridge connects major east-west transportation corridors in Guizhou and crosses terrain that was previously nearly inaccessible to vehicles, extending directly into Yunnan province. Due to the extreme depth of the gorge, the structure had to withstand powerful wind fields generated within the valley. Engineers ultimately selected high-strength, steel cable-stayed technology, balancing flexibility with structural stability. The bridge's extraordinary height was not purely a design choice. It was dictated by geology. Early designs proposed a much lower structure, but repeated surveys uncovered fractures and karst caves within the surrounding mountains. To avoid these geological hazards, the bridge alignment was raised again and again. This iterative process of testing, adjustment, and validation ultimately produced a bridge seemingly destined to claim the world record, though it also increased the budget by an additional $20 to $40 million. In the end, it proved entirely worthwhile. Before the bridge was built, many surrounding areas were barely accessible by road. The Beipanjiang Bridge fundamentally transformed travel in southern Guizhou. The province itself is defined by mountains, plateaus, rivers, and deep canyons, and the bridge forms a critical section of the G65 Hangrui Expressway. This highway links Kujing and Liupanshui, stretching an astonishing 2,935 kilometers from Hangzhou near Shanghai all the way to the China-Myanmar border. After the bridge opened, what once required 3 hours of winding canyon travel was reduced to just 5 minutes. The journey between Zhenxiong in Yunnan and Qianxi in Guizhou was cut from 5 hours to 1. As a result, the Beipanjiang Bridge is far more than a piece of infrastructure. It connects communities, enables mobility, attracts tourism, and directly stimulates economic growth in regions that were once isolated. It also represents regional integration, allowing people to move freely for the first time, no longer constrained by geography. At the same time, it stands as a symbol of China's engineering capability, financial strength, and global stature. China is famous for building extremely tall bridges, but the scale of its dominance is still startling. The country also holds the second and third highest bridges in the world: the Sidu River Bridge, standing 496 meters high, and the Puli Bridge in Yunnan at 485 meters. The Beipanjiang Bridge surpassed the Sidu River Bridge to claim the top spot, even though the Sidu Bridge itself cost nearly $100 million. Because of its dense network of deep valleys and gorges, Guizhou province alone hosts more ultra-high bridges than all other Chinese provinces combined, and more than the rest of the world combined. By 2020, Guizhou had over 250 bridges taller than 100 meters, making it the most concentrated region of high bridges on Earth. Italy, which ranks second globally, has only 40 bridges exceeding that height. Of the 20 super high bridges worldwide with deck heights above 300 meters, all but 3 are located in China. The Beipanjiang Bridge not only shortened travel times and shattered records, it created a man-made structure that blends seamlessly into one of the most dramatic landscapes on Earth. Even today, it continues to deliver convenience and global attention, proving that its $147 million investment was well worth the cost. While the Beipanjiang Bridge seemed nearly impossible to surpass, that record eventually fell. In 2025, the Huajiang Canyon Bridge, with a deck height of 625 meters, officially overtook it, becoming the new highest bridge in the world. Now let's step inside the world's highest bridge, the Huajiang Canyon Bridge. Before even opening to traffic, it faced one of the most extreme load tests in the world. 96 heavy trucks, weighing a total of 3,700 tons, were driven onto the bridge, while over 400 sensors monitored every stress point, deformation, and vibration in real time. And the result? It passed flawlessly. In doing so, it didn't just prove its safety, it rewrote the global standards for bridge monitoring and structural resilience. This isn't just a bridge, it's a statement, a declaration that the center of the world's engineering miracles is shifting to the east. So, what makes this bridge a true symbol of 21st century infrastructure? China is leading a once-in-a-century infrastructure revolution, building record-breaking mega projects at an astonishing pace. The nation's high-speed rail network now extends over 26,000 kilometers, connecting Beijing, Shanghai, Shenzhen, and Chengdu. It has become a global symbol of modernization and efficiency while laying the foundation for long-term economic growth. In 2023, China's investment in infrastructure reached $2.44 trillion, a 6% increase from the previous year, demonstrating its strategy of using infrastructure as the core engine for economic expansion and global integration. These massive investments not only expand global supply chains, but also create opportunities for technological collaboration and innovation, strengthening China's position on the world stage. One of the most striking examples is the Huajiang Canyon Bridge in Guizhou Province, an area once divided by rugged mountains. Scheduled to open in September 2025, the bridge stretches 9,480 feet in total length, with a main span of 4,660 feet, reducing the travel time across the canyon from 70 minutes to just 90 seconds. The Huajiang Canyon Bridge is not only a transportation link, but also integrates features like a glass walkway, bungee jumping, paragliding, and cliffside trails, making it a new tourist landmark comparable to the Golden Gate Bridge in San Francisco. Completed in just 3 years, this project showcases China's breathtaking construction speed, its ability to overcome extreme geographic challenges, and its growing strength as a global leader in modern infrastructure. The Huajiang Canyon Bridge is not only another milestone in the history of Chinese bridge engineering, but also a pinnacle achievement in the field of suspension bridges worldwide. On the map of Guizhou Province, you can hardly find any large flatlands. About 92.5% of the province is covered by mountains and hills, containing 1.258 million individual peaks, cut apart by 8 major rivers and countless tributaries that carve the land into bottomless gorges. Building an expressway across such terrain almost means confronting the very folds of the earth head-on. The Huajiang Canyon, located between Liupanshui and Shanshinan in Guizhou, serves as a crucial section of the Lian Expressway. To open this route, engineers face 2 choices: either avoid the canyon by detouring over the mountaintops, resulting in a smoother alignment but at an enormous cost, or lower the bridge height by adding more tunnels and steep slopes, making construction far more complex and dangerous. In the end, they chose the most extreme solution: to leap directly across the Huajiang Canyon in a single span at an altitude of 625 meters. At such an extraordinary height and span, ordinary bridge types, such as steel girder bridges, arch bridges, or cable-stayed bridges, were no longer feasible. There was only one answer left: a super long-span suspension bridge. The Huajiang Canyon Bridge has a total length of 2.89 kilometers, a main span of 1,420 meters, main towers rising 262 meters tall, and a bridge deck standing 625 meters above the canyon floor. It officially surpasses the Beipanjiang Bridge, becoming the highest bridge deck in the world. Upon completion, it will cut the travel time across the canyon from 70 minutes to just 90 seconds. But how do you build a bridge that holds the world's highest deck in one of the longest spans? In theory, it sounds simple. 3 steps. First, build 2 strong towers, then install 2 secure main cables and anchor them firmly. And finally, hang the bridge deck using vertical suspenders. Just like that, a suspension bridge is born. Of course, in reality, it's not that simple. To make the 262-meter-tall bridge towers stand firmly atop the mountains, engineers first had to find rock-solid ground, then drive 24 massive concrete piles deep into the bedrock. How deep? The deepest reaches 68 meters, about the height of a 20-story building. Above ground, each tower, more than 200 meters tall, was divided into over 40 segments. Using a hydraulic climbing formwork system, engineers poured and lifted each segment continuously, allowing the tower to grow upward at an astonishing rate of 0.8 meters per day. At the same time, they poured an enormous concrete anchor block, roughly half the size of Beijing's National Stadium. Why so huge? Because only with its 400,000-ton self-weight could it securely hold the 2 main cables, which would later bear the entire weight of the bridge deck. This is known as a gravity anchor. On the opposite side of the canyon, however, there wasn't enough space for such a massive structure. So engineers used the mountain itself as the anchor, embedding the cable deep inside a specially excavated tunnel, creating what's called a tunnel anchor. With both towers and anchors complete, it was time to install the main cables. From afar, these cables might look thin, but in reality, each is nearly 1 meter thick, wide enough for a person to walk on. But then came another challenge. How could these enormous cables cross a canyon more than 1,400 meters wide? The answer: drones. A drone first carried a thin pilot rope across the canyon, connecting both sides. That rope was then used to pull a thicker rope, and that one pulled an even thicker one, repeating the process several times until a temporary aerial walkway, known as a catwalk, was built between the 2 towers. Along this catwalk, engineers began installing the cable strands. Each strand composed of 91 high-strength steel wires, each just 5.7 millimeters in diameter. The first strand was the most critical. It served as the reference line for all subsequent strands. Using total stations on the ground and Beidou satellite positioning, engineers kept the installation error within 2 millimeters, ensuring that every following cable would be perfectly aligned and tensioned to precision. And when all 217 cable strands have been pulled into position, they are compressed and fastened together using a cable compactor, finally forming a single main cable. Once both main cables were fully tensioned, the project moved to the next critical stage, lifting the main girder. The main girder of the Huajiang Canyon Bridge weighs the equivalent of 95 Y-20 transport aircraft and was divided into 93 segments, which were assembled simultaneously from the center toward both sides. Each segment weighs 200 tons, roughly the same as lifting an entire blade set of the world's largest wind turbine. What made it even more difficult was that all this lifting had to be done under the constant threat of strong canyon winds. Thanks to a smart cable crane system capable of millimeter-level precision control, the main girder was finally joined seamlessly, marking the completion of the world's highest bridge's main structure. Construction of the Huajiang Canyon Bridge began on January 18, 2022. By April 2023, the first bridge tower had risen to 653 feet. In January 2024, the main suspension cables were fully installed. By January 2025, the main girder was joined, and in August 2025, the bridge underwent a full-scale load test. Finally, in September 2025, it is scheduled to officially open to traffic. In just over 3 years, engineers completed this record-breaking megastructure in terrain once deemed almost impossible for modern construction. During the load test, 96 heavy trucks, with a combined weight of 3,700 tons, were placed across the bridge, while more than 400 sensors continuously monitored stress, deformation, and vibration in real time. The results confirmed that the bridge meets the highest international safety standards, and through a digital twin system, a long-term health monitoring model was established to track the bridge's condition in real time. The Huajiang Canyon Bridge is not just a bridge. It is a smart megastructure integrating intelligent sensing, digital twin technology, and wind control systems. Equipped with over 400 high-precision sensors, it continuously measures temperature, wind speed, stress, and vibration, with all data transmitted to a central digital twin platform. This enables engineers to predict potential fatigue points, optimize maintenance cycles, extend the bridge's lifespan, and reduce maintenance costs. In terms of wind and vibration control, the bridge adopts a new aerodynamic deck profile and high-performance steel box girders to minimize the risk of vortex shedding and resonance. Additionally, LiDAR sensors continuously monitor wind speed and direction, while temperature control smart chips and cooling water systems embedded within the bridge towers help prevent structural stress concentration under extreme weather conditions. The significance of the Huajiang Canyon Bridge goes far beyond its technological marvel. It shortens the cross-canyon travel time from 70 minutes to just 90 seconds, allowing once isolated mountain towns to finally join China's national expressway network for the first time. The bridge sits along the Lian Expressway, a 94-mile corridor connecting western Guizhou with the Pearl River Delta, one of China's most economically dynamic regions. Its opening will not only boost logistics efficiency, reduce fuel consumption and vehicle wear, saving millions of dollars in economic losses every year, but also stimulate tourism, hospitality, and eco-industries across a 19-square-mile area. The bridge deck itself incorporates a glass skywalk, bungee platforms, Imagine a 24-kilometer highway that slices through the sea, combining bridges, artificial islands, and a 5-kilometer underwater tunnel. This is the Shenzhen-Zhongshan Link, a masterpiece of daring engineering. Over 4,500 massive cargo ships pass through its shipping channels every day, yet traffic is never interrupted. Engineers didn't just build a bridge or a tunnel. They created a seamless connection beneath the waves. Steel, concrete, and precision engineering work together to conquer nature. This is more than infrastructure. It's the underwater highway that turns impossible into reality. Dalian Bay isn't friendly. Winters plunge to minus 22 degrees Celsius, threatening concrete curing. Yet China built its first cross-sea immersed tube tunnel in the freezing north. 3 kilometers of massive concrete boxes. Each immersed tube section is 165 meters long, 46 meters wide, and 10.6 meters high. If stood upright, it would be equivalent to a 55-meter-tall building. Engineers floated them into place, sank them into the seabed trench, and pumped out the water to form a continuous roadway. This is not just construction. This is a battle with the elements, solved with innovation, precision, and relentless speed. An hour-long detour, now just 5 minutes through the tunnel. And just when you think that's unbelievable, China goes even deeper. 78 meters beneath the sea, under crushing water pressure, engineers are now boring a tunnel for high-speed trains at full speed. Meet the Gintong Undersea Tunnel, 16 kilometers long, with 11 kilometers running nonstop beneath the seabed. This is no longer transportation. This is humanity drilling straight through the planet. Every segment must withstand 7.8 atmospheres of pressure. One mistake could be catastrophic. 2 gigantic tunnel-boring machines, guided by lasers and satellites, carved through rock with millimeter precision. This is not just a tunnel. It's humanity rewriting the rules of engineering under the ocean. But China doesn't stop there, because the next tunnel isn't for trains at all. Welcome to the Yellow River Tunnel, the gigantic highway tube, not for rail, for cars, 17.5 meters in diameter, double-decker, 6 full lanes of non-stop traffic, rushing through the riverbed itself. China drilled through the Yellow River bed at record speed, 16 meters per day. The secret? A custom-built machine named Shanhe, devouring soft soil, installing concrete segments simultaneously. Incredible speed, extreme precision, and unfathomable scale. This tunnel transforms a massive river barrier into a 24/7 superhighway. This is the gigantic highway tube, where size, speed, and engineering collide. But China's engineering defiance of nature doesn't stop underground. Now, it goes vertical. Welcome to a battle between gravity and human ingenuity. The Three Gorges Dam ship lift, 3,000 tons, lifted 113 meters into the sky in just 40 minutes. No engines pushing it upward, only gravity, buoyancy, and pure mechanical genius. It's like stacking 30-story skyscrapers vertically and moving them in a single ride. Every mechanism is engineered to perfection. Every drop of water is harnessed. This is not a lock or a canal. This is the ultimate marriage of physics and human ingenuity. The ship lift shows what happens when you turn natural forces into precise engineering magic. But China didn't stop at lifting ships through mountains. Next, it lifted a bridge into the clouds, 625 meters above the river, nearly double the height of the Eiffel Tower. This is the Huajiang Grand Canyon Bridge. Steel and concrete stretch across a bottomless gorge in Guizhou, suspended in thin air, defying gravity, cross winds, and raw geological chaos. Cars don't just cross a river here, they drive through the sky. This is not a bridge. This is a ribbon of steel stitched into the clouds. Engineers battled earthquakes, typhoons, and steep cliffs to create this sky ribbon. It's not just a bridge, it's a lifeline, transforming a dangerous mountain trek into a 2-minute drive. Every glance down is breathtaking. This is the sky ribbon, beauty and engineering fused. But the sky isn't finished yet. 3 megatowers rise into the clouds. The tallest one reaches 332 meters, higher than the Eiffel Tower. This is the Ping-Tang Bridge. From a distance, its structure bends light, shape, and perspective, forming a perfect halo in the mountains. They call it the cosmic eye. And it's not art, it's a bridge. Engineers had to stabilize foundations on karst limestone, navigate underground voids, and resist fierce winds. It's a bridge, yes, but also a piece of art. Functional, monumental, and visually hypnotic. The cosmic eye isn't just engineering, it's a vision turned reality. And just when you think bridge design can't get any crazier, China builds one that carries 3 worlds at once. High-speed rail, city traffic, and a full-scale expressway. This is the Changtai Yangtze River Bridge, the triple transport monster, a single structure carrying 3 different transportation systems simultaneously. And with this 3-in-1 design, an 80-minute journey between cities is crushed down to just 20 minutes. 3 layers of motion, 1 unstoppable river crossing. This is not just a bridge. This is transportation stacked in 3 dimensions. Asymmetrical decks, diamond-shaped towers, and multi-load balancing, all engineered to perfection. It's not just a bridge, it's a transport revolution, connecting communities and rewriting regional mobility. This is the triple transport monster of the Yangtze. And just when you think China's bridges have reached their limit, it builds one that dares the open sea, 35.7 kilometers across the Hangzhou Bay, one of the longest sea-crossing bridges on Earth, directly exposed to the fiercest typhoons in China. This is the Hangzhou Bay Bridge. Here, hurricane-force winds slam into the structure, walls of seawater crash against it day after day. So engineers turn the bridge itself into a living structure. The massive concrete piers are designed to withstand hurricane-level waves. And the bridge deck? It doesn't fight the storm, it flexes with it, absorbing the violence of wind and water like a living spine. This isn't just concrete and steel anymore. This is engineering that bends, breathes, and survives the ocean. And when the sea itself becomes the battlefield, China doesn't retreat. It builds power stations on the water. Hainan Offshore Wind Farm. Hundreds of floating turbines rising from the South China Sea, some towering over 200 meters tall. These aren't just windmills, they're power factories, generating electricity for millions of homes. Engineers battled super typhoons, crushing deep-sea currents, and the relentless corrosion of salt water to anchor these modern leviathans. This is renewable energy on a scale that feels impossible, but China did it. The ocean turbines show what happens when energy, scale, and daring collide. And from the open sea, the challenge shifts to something even more vertical. Chongqing Monorail. Suspended over steep canyons and threading through dense city streets, this monorail climbs hills at impossible angles. Curves, tunnels, and bridges twist through the skyline like a steel roller coaster. Every day, it carries hundreds of thousands of passengers, connecting neighborhoods where roads could never exist. The mountain climber proves that urban mobility can defy gravity, terrain, and expectation. And just when you think engineering can't climb any higher, it goes into the sky itself. Tibet Ngari Airport, the sky-high runway. At 4,274 meters above sea level, Ngari Airport is one of the highest airports on Earth. Engineers fought extreme altitude, freezing temperatures, and thin oxygen-starved air to lay a runway capable of handling full-size jet aircraft. Up here, engines lose power, human lungs struggle to breathe, and every single takeoff becomes a precision duel with physics. This is more than an airport. This is where engineering reaches into the clouds. The sky-high runway stretches human possibility to its absolute limit. And while some of China's boldest engineering reaches upward into the sky, and there you have it, China's most insane jaw-dropping megaprojects, each one bigger, faster, or wilder than anything you've ever imagined. From tunnels under the ocean to bridges that defy gravity, from airports that feel like spaceships to entire cities built from scratch, from energy grids that light up nations to robots running the world's biggest ports. These aren't just feats of engineering, they are a statement, a reminder that when humans push the limits, the impossible becomes reality. So the next time you think a project is too big, too crazy, or too dangerous, remember this: somewhere in China, engineers are already building it, bigger, faster, and more precise than anyone thought possible. From high-speed rail to massive expressways, China seems to complete a mega project almost every day. Just 30 years ago, China had 0 miles of expressways. Today, it boasts the world's longest highway and high-speed rail networks, leaving the US far behind. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop.